Okay, let me give you another example of how one thing can be inversely proportional to another thing. So let's imagine you're sitting in a car traveling at 5 meters per second. So what that means is every second you would have done 5 meters. After another second, you would have done another 5 meters. After another second, you would have done another 5 meters. Now, if I were to ask you, how long will it take to travel a distance of 15 meters, traveling at 5 meters per second? Then you would just get let's call this d. You would get the distance divided by the speed. Okay, that would then give you the time. Okay, so in well, in this case, it would be 3 seconds. So you can imagine this as being like this: t equals d times 1 over s. Well, remember, when you times a fraction, it gets multiplied to the top. So we are just working in reverse. I'm just taking the d out. Now you can just imagine this as being a constant, just a number. So you can see that t is somehow related to 1 over s. So given this situation here, you can actually say t is inversely proportional to the speed. So you can actually write this. You can actually state this. So wait there. Hang on. Let me clear everything. So given this situation here, suppose you're talking about a distance of d. Okay. Traveling at a speed of s. Traveling at a speed of s. The time you can say that the time is inversely proportional to the speed. What that means is, hang on, time, speed. Now, if you increase the speed of the car, you will decrease the time it takes to cover that distance. Now, if you're traveling, if you decrease the speed of the car, then the time required to cover that distance will increase. So as you increase the speed, you will decrease the time. As you decrease the speed, you will increase the time needed to cover that distance. So whenever you're told that time is inversely proportional to the speed, you inside your mind you got to visualize something like this: time, speed. If you increase the speed, you decrease the time. If you decrease the time, you will increase the speed. Okay, so hang on. So let's looking at this scenario here, we've established that time is inversely proportional to the speed. Now let's try and plot this graph here. Let's imagine that we are looking at a distance of, let's say, 100 meters. Now, if we're talking about a specific distance of 100 meters, well, if you're traveling at let's say 1 meter per second, 1 meter per second, how long will it take you to cover a distance of 100 meters? Well, you would just get 100 divided by 1. So it would take you 100 seconds to cover this distance. Now, if you're traveling at 2 meters per second, and remember, we are looking at a specific distance of 100 meters. So if you're traveling at 2 meters per second over a distance of 100 meters, it would take you 50 seconds, okay, to cover this distance. Let's say if you're traveling at, let's say, 4 meters per second here, it would take you 25 seconds. Okay, we are looking at a specific case where the distance is 100. Now let's plot this on a graph. Hang on. So here, this is our graph here. Remember, we are looking at a special case where the distance is 100 meters. Okay. So this is the speed. Well, remember, don't forget, this here represents a time in seconds. So when you're traveling at 1 meter per second, it would take you 100 seconds, okay? Because this 100 here doesn't actually mean the meters. It actually means the time in seconds, because here it says time. in seconds. So this 100 here is 100 seconds. Okay. Now, if you're traveling at 2 meters per second, if you're traveling at 2 meters per second, then hang on. Let me get rid of this. Yeah. If you're traveling at 2 meters per second, it would take you 50 seconds to complete that distance. If you're traveling at, let's say, 3 meters per second, it would take you about 30 something seconds to complete that distance, and so on. You can actually continue, and the graph will look like this. So when you're told that t is inversely proportional to the speed, you can immediately visualize this graph here. Okay. Now let's look at a different scenario here. Let's look at a scenario where the distance we're talking about, rather than saying 100 meters, we are looking at a special case where the distance is just 60 meters. Okay. Now 60 meters, it will be a different graph, because 60. Okay. Let's say you're traveling at 1 meter per second. It would, well, 1 meter. Well, you get 60 divided by 1. So the time, it would take 60 seconds to complete that distance. Now let's say you're traveling at 2 meters per second. 60 divided by 2, so that would mean 30. It would take you 30 seconds to complete that distance, and so on. And you can continue, and your graph will look like this. Okay, well, it will look something like this. You see, this graph here, the k here is actually 100. You see, you've got a value of k where this value of k represents one scenario, and here the value of k for this one is 60. Don't worry if you don't understand this. What I'm trying to say is that the value of this k here, well, you've got lots of different values of k's. Well, each k represents a different scenario. For the 100 one, we are talking about a distance of 100 meters. For the 60 one, we are talking about a distance of 60 meters. So hang on. So when you're told that hang on, let me oops. Well, hang on. Sorry. So when you're told that that time is time is inversely proportional to the speed, you can, whenever you're told this, you can immediately jump inside your mind. You can immediately jump to something like this. Okay, and now so this graph is actually y equals k times 1 over or 1 over x. You can imagine it. So it's this thing here times this thing here, and when you times a fraction, it gets multiplied to the top. So you can imagine it as y equals k over x. Now the reason why you need this k here is because when you're talking about a distance of 100 meters, this k here is 100. When you're talking about 60 meters, this k here is 60. But the thing is, this k here could take on different values, and each different value represents a different scenario. I know it sounds a bit weird, but I will give you some exercises, and then over time it will make sense. Okay.